Okay, part A. Is this a binomial setting? Let's check the rules. And finite sample size? Yes, there's 25. One outcome won't influence the next outcome. That's true, unless, of course, they jumped on the phone and warned each other. But that's not going to happen in this case. Okay, so each outcome is either a success or a failure. So yes, each person called would either have lost money in their house or not. And the probability for success in this case is losing money in their house is the same for everybody. It's 0.8. So that part is true. So we do have a binomial setting. Bam. So what is X in words? X in words is out of the 25 people contacted, how many people will have lost equity in their house? That is the random variable. What are N and P? N is easy. It's 25, stated in the problem, as is P, and it's 80%. So what are all the possible outcomes of the random variable? So you got to think of everything that could happen. You could contact 25 people and only one of them lost money. Only two of them lost money, 3 of them, 4 of them, et cetera, all the way up to 25. So there's 25 there. But don't forget, you could also get a 0 probability. That means if you called 25 people and none of them lost money, that is still capable of happening. So your sample size is going to be 26. So just don't forget the 0 possibility rule. Okay, here comes the hard one. What is the probability that the random variable will be exactly 17? In other words, what are the chances that exactly 17 of these homeowners will have lost money? This is where the math comes in. So let's go ahead and pull up the math stuff. Okay, math time. Bam, there's the binomial probability formula. Right, the probability that the random variable will equal one specific number in our problem, it's going to be 17. So let's go ahead and do some math. Just plug and chug known values. 25 choose 17 times 0.8 raised to the 17th times 0.2 raised to the 8th. This is 25 choose 17, pretty big number. This is 0.8 raised to the 17th. This is 0.2 raised to the 8th. Go ahead and multiply all those out, and we get that number. It's rounded. I don't want to go out to 15 decimal places, but let's double check this in Excel. Please hold. So in Excel, pick a cell, any cell. You're going to go to statistical. We're going to go to binom dist. This one's kind of easy to use. It's a little bit different than the formula. The first number is the specific number of successes you're looking for. So in our problem, that's 17. Number of trials, 25. Probability is 0.8. And cumulative means that it would add up the probability of getting 17, of getting 16, getting 15, all the way down to 0. It would add all those up. We do not want that in this problem, so we're just going to type in false. Click OK. And we do get the same answer. So let's do the last one. So what are the mean and the standard deviation? Again, we're just going to go ahead and use the formulas. There's the binomial mean and the binomial standard deviation. So the binomial mean is kind of easy. It's it's 25 times 0.8. Comes out to be 20. What that means is if you repeated this experiment many, many times, on average, you should get about 20 people out of the 25 that lost money. So now for the final standard deviation, we're going to use this ugly formula. Just plug and chug the numbers. We get the square root of 4, which is commonly called 2. So that's it. MGZ.